For a planet having mass equal to mass of Earth, but radius is 1/4 of the radius of Earth, the escape velocity for this planet will be. So we know the equation for escape velocity, that is equal to under root of 2gm divided by r. Or you can write this escape velocity is directly proportional to root of m divided by r. Now for a planet having mass equal to mass of Earth, but radius is 1/4 of the radius of Earth. So over here the parameter which is changing is only radius, so we can write escape velocity is inversely proportional to root of radius. So we can write escape velocity on that planet divided by escape velocity of Earth is equal to under root of radius of Earth divided by radius of planet. And according to question, it is given that the radius of that planet 1/4 of the radius of Earth. So we can write as RE divided by 4. So thus RE and thus RE get cancelled. So we can write as root of 4, which we can take it as 2. So we can write the escape velocity on that planet is 2 times of escape velocity on Earth. And we know the value of escape velocity on Earth's surface is 11.2 km per second. So it is going to be 22.4 km per second.